Today we're going to talk about the mean value theorem, which is another type of rule theorem. If you understood yesterday, you should understand today. There's only one more step. So think about this situation. If you're going on a road trip, and at noon you get on a toll road, you pick up the toll entrance and ticket, and you're at mile marker 1. There's a speed of 55 miles per hour, but you don't see any police. And at 2, you exit the toll road at mile marker 141. The attendant hands you your toll ticket, and it says $5 for the toll and $125 for speeding. So think about just for a second, how did the attendant know that you were speeding? So the attendant would know you're speeding because you traveled 140 miles in just 2 hours, which means your average speed was 70. So in order for that to be an average, we should hopefully understand that you had to have been going above that and below that at some point during your traveling. Which is where the mean value theorem comes from. So suppose f of x is a function, so it's continuous and differentiable. So it starts out the same as Rolle's theorem, except for instead of there exists a number c such that the slope is 0, there exists a number c such that the slope of the tangent is equal to your average rate of change, or your average slope. So the attendant knew you were speeding because if your average speed was a 70, there has to have been a point during your drive where you were going 70 miles per hour. So this time, instead of there being a point where the tangent's equal to 0, there's a point where the average, slope of the tangent is equal to your average rate of change. This is helpful. It's because your f of a and your f of b do not have to be equal. So it just means that if you connected this point f of a to this point f of b, and let's say that slope was 1/2, then if this is continuous and differentiable, there has to be at least one point on this curve where the slope of the tangent is also 1/2. So we've already talked about how Rolle's and the mean value theorem are related, but just to be clear, Rolle's theorem only says there has to be a tangent line where the slope is 0, but your points have to be equal. The mean value theorem, your points don't have to be equal. One can be down here and the other up here, but it just says there has to be at least one point where the slope of the tangent equals the slope of that line segment. They both have to have continuous and differentiable functions. Okay, so for this problem, we're going to use the mean value theorem. So I still have to say that this is continuous and differentiable. It is a parabola, so it is both. I no longer have to show that it's equal at its endpoints. But I do have to find out what the average rate of change is between those 2 points. So if I'm going to do that, I'm going to do f of 3 minus f of 1 over 3 minus 1. And so if I do that, I do 9 minus 1 over 2, or 8 over 2, which is 4. So this means that if I were to connect these points, so 1, 9, 1, 1, sorry, and 3, 9, that segment, that secant, has a slope of 4. So we want to know at what point does the original function f of x also have a slope of 4. So in order to do that, I am going to take the derivative. But this time, we're not looking for Rolle's, we're looking for the mean value. This is the mean, the average. So we want to set it equal to the average. And I find that that happens at x equals 2 or when c equals 2. Okay, for the second example, if I look at this function, x to the 2/3, this is going to be continuous, but if you know something about this graph, or if you look at it on your calculator, when you take this derivative, you're going to get an x to the 1/3 in the denominator. The graph actually looks like this. So this point right here is 0. There's a cusp, which we know is not differentiable. And since 0 is in that interval, we would say the mean value theorem cannot be used because f of x is not differentiable, hopefully I have enough room, on -1 to 8. So I can't take a derivative right there. That causes me an issue, so I have to just say I can't use it. Okay, this is a parabola, so it's going to be continuous and differentiable. So I don't need to set my endpoints equal. I do need to find my average rate of change. So 1 minus 9 is -8. 1 minus 0 is 1. So -9 over 3, so -3. So I'm going to take my derivative. Pen is messing up. So I get -2x. I want to know, when does that equal -3? That happens at 3/2. And so I would say when c equals 3/2, is is the value of c that satisfies the mean value theorem. And that one's pretty straightforward. Okay, this is a cubic, so it's going to be continuous and differentiable. So I need to find my average rate of change. So if I put -1 into this, I'm going to get -1 plus 1, which is 0. If I put in 1, I get 1 minus 1, which is 0, over -2. So I'm looking for when the mean value is 0, or for when the slope is 0. So if I take the derivative, I set it equals 0, then I would add 1. So I get 3x squared equals 1. So divide by 3, and to get rid of the squared, I do plus or minus the square root. So my answer would be when c is equal to plus or minus the square root of 1/3. So this is actually an example of the mean value theorem as Rolle's theorem. Because it's equal, and we're setting it equal to 0, but we're still using the mean value theorem because that's what they asked us to do. Okay, so this is a word problem. So it says it took 40 seconds for hot chocolate to cool from 200 degrees Fahrenheit to 136 when an ice cube was added. True or false? At some point during the 40-second interval, the hot chocolate was cooling at a rate of 1.6 degrees Fahrenheit per second. So I'm going to use mean value theorem, or try to use mean value theorem, because it didn't ask me to set it equal to 0. So I'm going to just see if we went from 200 to 136 and it took us 40 seconds to do that, then that would be 64 over 40, which is 1.6. So the average rate of change is 1.6. So that means if this is continuous and differentiable, it had to have been cooling at a rate of 1.6 degrees per second. So there's nothing about something cooling off that's going to cause any jumps. It's not going to spontaneously change temperatures. So it would be continuous and differentiable. And so by the mean value theorem, this is a true statement. Okay, for this problem, is it continuous? Yes, but with absolute values, we have to be careful with those corners. So the question is, where is this corner? So I would set what's inside equal to 0, and I find that the corner is at 2, so it looks like this. Well, we're going from 0 to 4, so that's inside my interval. So I would say you cannot apply the mean value, sorry for my terrible handwriting, theorem, because f of x has a corner at x equals 2. So it doesn't meet the conditions, you can't apply it, and that's it, we're done. Okay, this is a natural log. There's nothing wonky about it. It would, especially in the interval 2 to 4, so we're good. So we're going to find the average rate of change, or the mean value. So if I apply 4, I get natural log of 3. If I apply 2, I get natural log of 1 over 2. Well, the natural log of 1 is just 0, so this is really natural log of 3 over 2. So when I take this derivative, it's 1 over what's inside the natural log times its derivative, but the derivative is 1, so we're good, over natural log of, or equals natural log of 3 over 2. And so I would probably multiply both sides by natural log of, x minus 1, and the other side by 2. And then I would divide by natural log of 3. And then add the 1. So the answer would be satisfies the mean value theorem when c equals 2 over natural log of 3 plus 1. I would not, for any reason, make that a decimal. Natural log of 3 is exact, so let's leave it at that. Okay, so for this one, is it continuous? Yes. Is it differentiable? There would be a problem at 1, but 1 is our endpoint. And if you've paid attention to your definitions, it says it's differentiable on the open interval. So it does not have to be differentiable at those endpoints, just inside of them. So we're good. So we'll come back and we'll find the average rate of change. So if I put in 3, I get square root of 2. Put in 1, I get square root of 0, or 0 over 2. So I get square root of 2 over 2. So when I take this derivative, I get 1/2 x minus 1 to the negative 1/2 times 1. And I want to know, when does that equal square root of 2 over 2? Well, really what I have here is this rewritten. So I can multiply both sides by their reciprocals, or both sides of the function by the reciprocals. So if I multiply by 2, I'll do it in several steps for you. So I moved this 2, I multiplied all this by the square root of 2, so there's the square root of 2, there's this 2, and there's the square root. So I can divide out a 2, and I get 1. And I can divide by the square root of 2. If I'm going to get this x, I need to square both sides. So I should get 1/2 equals x minus 1. And when I add 1, I get 3/2. That was a lot of work. But again, what's going to get you in calculus is the pre-cal or the algebra 2. So be sure that you're comfortable working this out. So my final answer would be when c equals 3/2, or c equals 3/2 is the value that satisfies the mean value theorem for this function. Okay, I'm going to now work through the ones that are on your worksheet just like I did last class. So you can pause this, go work on that, come check yourself. If you're not sure how to do it, you can come watch me do it, whatever you need to do to be successful. So this is a cubic. It's going to be continuous and differentiable, so we're good. So we're going to find our average rate of change. And so if I put substitute in 3, I get 27. Negative 2 would be negative 8. So minus negative 8 is plus 8 over 5. So that should be 35 over 5, which surprisingly is 7. Pretty simple. So then I would take my derivative. I get 3x squared. I want to know when does that equal 7. So I divide by 3. When I take the square root, I can't forget the plus or minus. So my answer appears to be plus or minus the square root of 7/3. I just need to make sure that's within my boundary. 7/3 is just less than 2, so it's going to be fine, so I need both of them. So when c equals plus or minus negative 7/3, the mean value theorem, the function satisfies the mean value theorem. Okay, is this continuous? Yes, absolute values are continuous, but we have to watch out for those corners. So they occur where the interior is equal to 0. So that would occur at negative 3/5, which is greater than negative 1 and less than 4. So that's inside my interval. So you would say you cannot apply the mean value theorem because f of x has a corner or is not differentiable at x equals negative 3/5. So that got you out of that one. You're good. Keep going. Number 3 is going to be continuous and differentiable. So we just need to find the average rate of change. So we would do f of 0 minus f of negative 4 over 0 minus negative 4. So if we put in 0, we get 7 plus natural log of 5. if we put in negative 4, we get minus 7 plus natural log of 1 over 4. So natural log of 1 we know is 0. The 7s will cancel, so we'll get natural log of 5 over 4. So if we want to find where the derivative of the function equals that, we would take the derivative, so it's derivative of 7 is 0, so it's 1 over x plus 5 times the derivative of x plus 5, which is 1. So that equals natural log of 5 over 4. So we would cross multiply, divide by natural log of 5, and then finally subtract 5. So x would be 4 natural log of 5 minus 5, so the answer would be when c equals 4 over natural log of 5 minus 5. Okay, so it's going to be continuous. It's not going to be differentiable at negative 4, but again, that's differentiable in the open interval, so we don't care about the endpoints, so we're good. So if we find the average rate of change, so if I substitute in 6, I get square root of 10, negative 4, I get 0. So it's square root of 10 over 10. So I want to know, when does the derivative, which is this, equal square root of 10 over 10? So I would probably rewrite this. And then from here, this is not algebra. This is not calculus. This is just algebra. A little bit complicated, but it's not impossible. It's just easy to make a mistake. So if I multiply both sides by their denominators, I can divide by 2 and I get 5, or divide by 2 square root of 10, I get 5 over the square root of 10. Now I want to get rid of those square roots, so I'm going to square. You don't have to do that there, but I don't see really why you wouldn't. Then subtract 4. So 25 over 10 reduces to 5 halves minus 4. So really 2.5 minus 4. So negative 3 halves. So the answer would be when c equals negative 3 halves. So that one wasn't complicated, other than the fact that you had a square root and then you had to do some fancy algebra work. Okay, this is cosine, so it's going to be continuous and differentiable. So let's find our average rate of change. Okay, so if I put 7 pi over 6 into this, I'm actually taking the cosine of 7 pi over 2, because it has this 3. So that would be 3.5 pi, so 2, 1 rotation's 2, half, so it would be down here. So the cosine of that is 0. If I put in pi over 6, I'm actually taking the cosine of pi over 2, which would be up here. So again, 0. So the numerator is going to be 0, so the denominator is actually irrelevant, but 7 pi over 6 minus pi over 6 is 6 pi over 6, or just pi. But that comes out to 0. So I want to know, where does this derivative equal 0? Well, it's cosine, so it's going to be a negative sine 3x. Derivative, the chain rule, derivative of 3x is 3. So I want to set negative sine 3x equal to 0. I can divide by a negative 3. So I get sine of 3x equals 0. And sine equals 0 at the zeros and the pi's. But we have this 3, so it'd be 0 pi over 3 pi over 3, we need 3x to come out to be 2 pi, so I believe it would be 2 pi over 3, and then if we want it to come out to be 3 pi, we would just put in pi, maybe one more, so this would be, sorry about that, this would be our 0, this would be our pi, this would be our 2 pi, this would be our 3 pi, so if we wanted it to be 4 pi, then it would be 4 pi over 3. Now all of those places, sine of 3x does equal 0, but we have an interval up here. So it doesn't start till pi over 6, which knocks out 0. And then it goes to 7 pi over 6. Well, 4/3 is greater than 7/6. So that's out. So it would be these 3. So the answer would be when c equals pi over 3, 2 pi over 3, or pi. Okay, this one is a cubic, so it's going to be continuous and differentiable. So let's find our average rate of change. So if I substitute in 2, I should get 0. If I substitute in negative 3, I believe I get negative 5 over 5. So 1. That was easy. Take the derivative, so I get 3x squared plus 4x minus 4, and I want to know, when does that equal 1. It's a quadratic, so I'm going to move this one over. I don't think this is going to factor very well. You could try it, but I can't think of anything that multiplies to give me negative 15 that gives me a difference, or a sum of 4. So I'm going to go ahead and do quadratic formula. So it would be negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 4 plus or minus 6. The discriminant is 76. We can factor a 4, out of that. Square root of 4 is 2. So 4 times 19 gives me 76. So that can reduce to this. But I need to check within my interval. So negative 3 to positive 2. So square root of 19 is going to be 4 point something. So it would be 1 point something over 3, which is fine, and negative 6 point something over 3, which is also fun because it's negative. Sorry, I confused myself with the 2. So my answer would be when c equals -2 plus or minus the square root of 19 over 3. And we're back to a trig one, which are more difficult just because you have to think through things like the unit circle. But it's going to be continuous and differentiable. So let's go ahead and find our average rate of change. Okay, so if I put 5 pi over 4 into this, I'm going to get 3 pi over 4. It's going to be out here. So those are the square root of 2 over 2's. So it's going to be square root of 2 over 2 minus, if I put in 3 pi over 4, I'm going to get pi over 4, which is going to be square root of 2 over 2. Most of these are going to end up equaling 0 because it's really mean to ask you to do that otherwise. So it doesn't matter what the denominator is because the numerator is going to be 0. But it is pi over 2. So all that is going to equal 0. So we'll take our derivative. So derivative sine is cosine. X minus pi over 2. The derivative of the inside is still 1 because it's not times pi over 2. So we set that equal to 0. So we have to think about where does cosine equal 0? Well, that happens at the pi over 2's and the 3 pi over 2's. But because of this minus pi over 2, we're going to have to go half a pi past that. That's a pre-cal skill, so hopefully you're starting to remember that or be able to think through it. I have to think through it. I'm not good at translating trig functions or transforming them. So my first stop is going to be at pi, and then 2 pi, and then 3 pi, 4 pi. That seems odd, but it's right. So my interval is 3 pi over 4 to 5 pi over 4, so there's only one answer. The rest of those are outside my interval. So it would be when c equals pi. So that was a lot of work for a very boring answer. Okay, so for this, I need to first check continuity. There's a problem here. This interval goes to 5, but if I were to put 5 into this, I would get 4 minus 5 square root of -1, which is I, which we don't like imaginary numbers in calculus, so this is not possible because f of x is not defined on the entire interval. So that's good. We have nothing more to do with that one. Okay, this is only going to have problems at -4. That's outside my interval. So I'm going to go ahead and do the average rate of change. Okay, when I put in 5, I got 0. When I put in 0, I get -40 over 4. So that would be -10. So that reduces to 2. So I want to know, where does this derivative equal that? Well, this is quotient rule. So it's Dahai Ho minus Hi Daho over ho. And then again, there is value in cleaning this one up, because if not, you're going to have a hard time solving it. Multiply by 1, it doesn't do anything, but you do have to distribute that negative. Alright, so we get x squared. 8 plus 3 is 11, minus 3 is 8. 12 plus 40 is 52. Over x plus 4 squared. And we want to know, when does that equal 2? Well, that is unfortunate for us, because that means we can't just pay attention to the numerator. So we're going to multiply by x plus 4 squared. We may be going down a rabbit hole here, but we may work it out. So we get x squared plus, that would be 8x plus 16, but I have to distribute a 2. So it's 2x squared. 8 times 2 is 16. 16 times 2 is 32. So if I subtract everything over, then I would get x squared plus 8x minus 20. That factors to x plus 10, x minus 2. So it'll be negative 10 and positive 2. Negative 10 is not in my interval, so the answer would be when c equals 2. This right here was a stretch. It was difficult. Not difficult, tedious, but it's an algebra 2 skill. It's just, you're gonna have to shake some cobwebs on that one. Alright, for this one, it's gonna be defined, continuous, differentiable, everything's good. So we would do f of 2 minus f of 0 over 2 minus 0. So it would be e to the 4th minus e to the 0 over 2. Well, e to the 0 is 1. So e to the 4th minus 1 over 2. So we want to know, where does the derivative, where does the derivative, and e to the 2x is just e to the 2x, and the chain rule gives me the 2. Where does that equal e to the 4th minus 1 over 2? Well, I can multiply by 2 to clean up that side. Okay, so we got rid of that 2. Now I'm gonna divide by 4. And this is just pre-cal. It's annoying, but it's doable. Just remembering those rules. So if I take a log of a quotient, I can rewrite it as a difference. So I'm going to do that. Okay. Then I can, the natural log and the e cancel. So I get 2x equals, equals this mess. Divide by 2. So your answer is when c equals natural log of e to the 4th minus 1 minus natural log of 4 over 2.